We were discussing about radio in the previous session. So now we'll how to calculate the distance, okay? The range or whatever we call it as yeah, the maximum line of sight distance between two antennas, okay? I have two antennas. Okay, so I have two antennas. Let us say this is antenna number one. Let us say antenna number one, and this is antenna number two. Okay. So there is something called your DM. Okay. So that is your maximum LOS, line of sight distance. Okay. That the radio wave can travel. Okay. So let us say this height of this antenna, my height of this antenna is equal to the transmitting antenna. Let it be HT. Okay. Let it be HT, the height. Okay. Height of the antenna is HT, and in the receiving side, let us say it is HR. Okay. So let us say this is HR. So the total distance that it can travel, let us say from here to here, this is the total distance it can travel, right?
Yeah.
So this distance we call it as DM, total line of sight distance a radio wave can travel. Okay, so so the formula for this, there is a very simple formula for this. Let us say our here at this point my radius of earth is r. Okay, radius of earth is r, and here also let us say my radius of earth is r. That is radius of earth, it remains constant. So throughout it will remain constant. Okay, so my dm, the formula for my dm is equal to 2 into rht, 2 into radius of r, rht, plus 2 into r, h, then this is the receiving side. So this is the total distance it can cover. This is the maximum distance it can travel. So here you can see from this equation, your dm is directly proportional to square root of r, is directly proportional to the height of the antenna. So higher is the height of the antenna, more is the distance it can travel, and higher is radius of earth anyway is constant. So the distance travel is a function of height of the antenna. Okay. So this is a simple numerical. There can be numerical related to it, because in communication system there you don't have complex numericals. If you remember these simple formulas also, because there bound to be a question in communication system. So if you remember this simple formula, you can get a question on this. Okay, or there can be some like say if you the questions based on your understanding, like what is the function of a carrier wave, why do we need modulation, all that I have explained. Okay. So this is about the distance a radio wave can travel. Okay, and then we'll do a numerical related to modulation. Okay, what is modulation index and all. Okay. Those are very simple things. That's why we should do it. Okay. Okay, so you will do it with the help of a numerical on modulation, amplitude modulation. Okay. So, numerical example on amplitude modulation. So, the question is like this. So, regarding modulation, you know, like you have so you have a carrier. You can say you have modulating signal or base signal. So you have a base signal. Okay. You have a base signal which is otherwise called as modulating signal. Modulating signal. Okay. And then you have a carrier wave. Okay. Carrier signal or carrier wave. So these two things are mixed. So these two things are added. Okay. Then after this is being these two things are added with each other. Okay. So this base signal will be a simple low frequency wave. Okay. Whereas your this carrier signal will be a very high frequency wave kind of. Kind of. So these two waves are mixed with each other so that the resulting wave will be of a very high frequency so that it will be easy to transmit it. Okay. So one numerical is given. So yeah. So the question is like this: a message signal of frequency 10 kilohertz and peak voltage 10 volt. Okay. So this is
10 kilohertz.
This is 10 kilohertz is its frequency and 10 volt is its 10 volts is its amplitude. Okay, so this is the electrical signal. That's why we define it in volt. Okay, you are converting the pressure or temperature or whatever
into
electrical signal. So you have 10 kilohertz and 10 volts as your base signal or the modulating signal. Okay, and you have a carrier wave whose frequency is 1 megahertz and voltage is 20 volt. Okay, so here it is 1 megahertz and 20 volt. Okay, so this is your carrier wave. Okay, so you can see why the frequency is high because so frequency is number of altercation in 1 second.
Yeah.
So because there are so many altercation in a second, you find that it is kind of a the number of altercations are very high. Okay. So here the voltage is 10, here the voltage is 20. Okay, so this is the carrier wave. Okay, so they are asking what is the modulation index. Okay, so you are modulating it this wave by using a carrier wave. So the question is what is modulation index? Modulation index. Okay, so the modulation index is just a formula you have to remember: the amplitude of the base signal divided by amplitude of the carrier signal. Okay.
Ratio.
So yeah, so modulation index MI is equal to amplitude of base signal divided by amplitude of carrier signal. Okay. So you forget about frequency, only the amplitude. Okay. So this is equal to 10 volt divided by 20 volt, which is equal to 0.5. Okay. So this is simple things. Just remember it is amplitude of base or modulating signal divided by amplitude of carrier wave. That's the modulation index. Okay. And one important thing is this modulation index should always be less than 1 to avoid distortion. So this is otherwise written as nu. So nu should always be less than 1 to avoid distortion. So that means the carrier wave should have higher amplitude as compared to the base wave to avoid distortion.
Yeah.
Okay. Then the another question is the size of band produced. Okay. What is the size of the band? So bandwidth. Okay. Bandwidth.
Yeah.
Okay. So this is the whatever the resulting wave you get. What is that size? Okay. So that size is equal to the carrier wave. So max, there will be two things. One is max, one will be mean. Okay. So the max will be, so let us say this is 1 megahertz. So 1 megahertz is nothing but 10 to the power 3 kilohertz. Okay.
Yeah.
Plus 10 kilohertz. Okay. So this is 1000 plus 10. Okay. So 1010 kilohertz. This is your max. And then the mean is 10 to the power 3 kilohertz minus 10 kilohertz.
Okay.
Okay, so this is 1000 minus 10, which is 990 hertz.
That is
So
the range.
so that's the
Range.
range of the
Bandwidth.
the
Frequency.
range of the new
So
signal that is
bandwidth.
being. So this is the map. So
Bandwidth.
earlier I was telling like another advantage of modulation is, suppose you are speaking here, I am speaking here. So at this low frequency there are chances that suppose somebody want to listen to you. So my frequency, your frequency can interact, and the final thing will be you cannot. It will, the quality will be very bad. So that's why if you do modulation, you add a very high, make it a high, very high frequency, give a different band. You have a different band, I
In
have
a
a different
certain
band.
bandwidth only.
So there will be less chance of interference.
Yeah.
And that is another advantage of modulation.
Modulation.
Okay, so I have just discussed about few numericals related to transmission system
And bandwidth.
and the distance and all that. So here the numericals will be very very easy. Just if you remember these formulas, you can solve. Okay. So this is about the numerical, and then some quick things on what are the applications of internet. Okay. So you have taken it?
Yeah.
Okay. So those are theoretical questions. You know it. You know how important is communication nowadays. How important is internet. So what is internet? Okay. So So some important. These are. We are using it day in and day out, but we have never tried to understand the in-depth meaning of it. Okay. So internet. Okay. So inter comes from interconnectivity. Okay. Interconnectivity. Inter stands for interconnectivity. Net comes from the word network. Network. So internet means interconnected network. So we are using the abbreviation. Okay. And then there is something called LAN. Okay. LAN is nothing but your local area network. Area network. Okay. Then what are the different applications of internet that you know already, like internet surfing or your email or your e-banking application, whatever fund transfer or whatever transaction you do, or you can apply for loan, all these e-banking applications, and then your e-shopping, that e-commerce, whatever you are purchasing through Amazon or any Flipkart or whatever. So those are all the advantages of internet or applications. Similarly, your e-book, okay, e-library and all that. And e-ticketing, like whatever the railway ticket booking, air ticket booking, all these things, and also social networking, whether you're Twitter or Facebook or in Instagram and all. So the communication system has huge application, and there is a lot of innovations and research going on in this area. So you can see in every 6 months things are changing. Okay, like say 2G to 3G to 4G to 5G, and then from wired communication, copper wire to fiber optics and all these things. Okay. So a lot of research going on in the area of communication system. So it is so important to understand all these things. So this is electromagnetic waves, which is kind of a ground wave or a sky wave or space wave, and how we using geostationary satellite, this TV communication, what are the different bandwidths allotted for different AM, FM, TV, and all that we have discussed. Okay.